does it? Okay. That doesn't help us at all either. Wow, guys, I'm sorry. Here we go. Yeah. Yep. Which of the following could be the slope field for the differential equation? Okay, at first I see it's all in terms of y, which means given one y value, which is a horizontal line, all the slopes should be parallel. Bless you. So right away I can say those slopes are changing along horizontals, forget him. Those are changing along horizontals, forget him. Those are changing along horizontals, forget him. I'm down to these two. Just because in terms of y, for one y value, all the same slope. If it was in terms of x, for one x value, all the same slope. So A or C. No, A or E. And then y squared minus 1. Well, if y was 1 or negative 1, I should have horizontal tangents, right? Because then the slope would be 0. So I see horizontal tangents seemingly at a positive and negative. Horizontal tangents, this is 2. So 1 would be half. Yeah, no, only A makes sense, right? Because a horizontal tangent at a negative 1, horizontal tangent as a positive 1 only works for A. Yeah. Anything else between 1 through 28? Non-calculated multiple choice. Sally? 11? Yeah. Number 11. Let R be the region. Ooh, it's an area question without a calculator. Let R be the region between e to the negative 2x and the x-axis. Are we okay using our basic graphs, realizing there's a negative on the inside, that it would be some sort of, horizontal flip? Are we okay with that? E to the x goes swoop, e to the negative anything will reflect, right? Swoop. That would be really helpful because when it says x is greater than or equal to 3, I don't know what's going on, but I can at least say it's flush with the axis, which I'm not revolving, so I don't have to think disks or washers or shells. But for area between, it's helpful to know that I am going, what's my upper bound? Infinity. It's an improper integral. Yeah, it's right, proper integral. But yeah. That's what my next one's going to be, the limit as b goes to infinity. Let me get back to that. It's e to the negative 2x would be my top. My bottom is just the axis, which will just be 0. So it would be minus 0 just ends up being him. When I integrate, I'd have to do a little bit of u sub. I have a negative 1/2 e to the u. Because remember, integrals make that a b, limit as b goes to infinity. I anti-derive. It's time to plug and chug. And so I end up with the limit as b goes to infinity. Are we all okay with me putting this in the denominator? Because it's a negative exponent, right? Same thing here. So I'll have minus a negative, which will be a positive 1 over 2 e to the 6. As b goes to infinity, isn't that guy going to 0? You guys can tell. Dun, 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 dun. Sally, does that make sense? Okay. Yeah, that one was nasty because in only BC can it make a bound infinite. Then life gets exciting. Anything else 1 through 28? Okay, drop on by 0 period after school to ask me if there's more. But for right now, we're going to calculated multiple choice. And if I were you, have your calculators out just in case there are a few things that you guys aren't knowing you can, should be able to do, etc. What was number 22? Wait, did we even look at that one? Did we look at that one yesterday? What was 22 and why was it only 14%? Oh, it was yeah, nice. Does that make you feel better? Yeah, but you were in really good company in the sense of probably like 75% of the kids passed the exam with a 4 or 5, and 14% of the total population got it right. So anyway, yeah, it was a hard one. But now you know at least something like that has to be integration by parts. There's no other way for us to integrate separate functions in an integral. Anyway, that makes way more sense. All right, 76 and beyond. Maggie.
Number 8 is kind of down here.
That's okay. 8, 0?
Yeah. So I graphed it.
Graphed what?
The first derivative.
Good.
And I only saw 4 zeros.
Okay. Let me do a quick, actually, if I were you guys, I would grab out a colored pen with notes, or I would go in the When You See, You Think and go find where it talks about points of inflection, because I'm about to do a quick rundown of how the AP will require you to think about points of inflection in general. First of all, when they say points of inflection, don't they mean actual, right? Not possible, but actual. Second of all, if it's not just possible, but actual, I need to have a pip. I need the second derivative to be 0 or DNE. True? And I need a sign change. True? Yeah. So if I have the second derivative and I'm allowed to use my calculator, AB had something super similar. If I have the second derivative, or I can find it, which I could do with the product rule if I really wanted to, I could use the zeros of my calculator, right, where my graph changes, because I would be graphing my second derivative, changing from above to below, or below to above. What am I talking about? If you're looking at the second derivative graph, aren't you just caring about the y values changing sign, right? So zeros or DNEs, careful. Zeros, what was maybe a swoop vertical asymptote. A hole, it's going to be a little bit rougher. But a hole, they'd have to show us clearly. It could be like at a sharp point or something, but they'd have to show the hole. So careful. Zeros, we're looking for actual intersections, or we're looking for domain problems. Ooh, pre-cal. When you see, you think. Anyway, domain problems of the second derivative. What if we have the first derivative? Because, come on, let's be honest. Do we really want to take a derivative of this if we could do it with this guy as is? Not really. So, okay, the first derivative. Quick reminder. If f double prime is positive or negative, doesn't that mean that f is concave up or concave down? I don't know if I did it last year, but I did this year in the Calc AB Forever cards. What's f prime doing? Because his derivative is positive, his derivative is negative. On concave up, the slopes are continually going from more negative to more positive. They're increasing in their numeric value, or going from high positives to zeros to negatives, they're decreasing in their numeric value. So what does that mean? Well, if there's going to be a sign change of a second derivative at a 0 or a DNE, isn't that going to mean there's going to be a relative min or max of the first derivative? So I'm looking for relative extrema, basically, or points at which f prime changes from increasing to decreasing, or decreasing to increasing. Could be smooth or could be sharp. Mm-hmm.
So I just need to clarify. When you're saying from increasing to decreasing, talking about
The f prime graph, no.
Oh, so we're actually talking about the y.
The f prime graph, the y's of the f prime.
Okay, so yeah, then I definitely don't know what happened. I don't know why it's fine.
And if you had f, we would actually have to find the points at which the concavity. Okay, I want you in your calculator to quickly go to the second trace menu. Yeah? Second trace menu in your graphing calculator. Is there a points of inflection option? No. So is it possible to find points of inflection with an F graph? No. Now, can you visualize, can you see concave down, concave up, and be like, I think there's one there, or I think there's one there, or I think there's one there? It's But you could approximate, but you can't find it. There's absolutely no precise way from an F graph to find a point of inflection, which means even if they give you F, don't use it unless you just want to visualize. If you need to find it precisely, have an F prime or have an F double prime. Nice thing is what they give us. The derivative. If you throw this derivative function into your graphing calculator, we're not looking for zeros or DNEs where it goes from above to below or below to above. That would be of the F double prime graph. If we're looking at graph him on. In the second trace menu, you don't have points of inflection, but you do have maxes and mins. So if I needed to find points of inflection, I could find maxes and mins of F prime. But guys, they don't even ask me to find it precisely, even though I could. They're just asking me to count. So how many hills or valleys or hills? Anyway, how many maxes and mins do you see from -2 to 2 of this guy? Make sure you're in radian mode. There's 5. You were thinking it was him when it was him. But if you were to do product rule and graph him, you would have seen 5 zeros where it would have changed from below to above or above to below. Is that cool? But knowing the AP, if they gave you the second asymptote in there too, just to throw you off. Yeah, good question. And good AP coverage as to what your calculator can and can't do with points of inflection. What else do we have? 76 to 92 or something? Hannah? 88. Okay. I should show you guys the CalcAB one that got 10% got it right. 11% got it right. I don't know. It was a really low one. It was a table too. Except for this one, they give you an accumulator function set up, right? You might not remember, but the AP loves to put this guy in FRQs. The AP loves to put this guy in FRQs. Now, nowhere in here does it specifically say, hey, you should think about who G prime is, and hey, you should think about who G double prime is. Nowhere in here. But if you saw this on an FRQ, I can guarantee you they would ask you about G, which would be areas. They would ask you something about a G prime that you had to find, which you would need to take the derivative of who G is. Guys, how do we take a derivative of an integral? F of u times u prime, which would be f of x times 1. So if they're talking about f, isn't he just g prime? And then g double prime would be his derivative, which would be f prime, right? So what does that mean? When I read f is positive and increasing, f is positive and f is increasing, doesn't that mean that g prime is positive and g double prime is positive? If f is positive and f is increasing, that means his derivative is positive, then I can relate it to g by saying oh and oh, which means g is increasing and concave up. Now what does this mean? G's y values are going up and going up at rates, faster increments, aka think concave. What's the easiest way of doing this? Think concave up. Wouldn't your rise over run for tangent lines, wouldn't they get steeper and steeper and steeper, aka bigger changes and bigger changes between the y's? Concave down is smaller changes and smaller changes because the rates or the slopes are decreasing. So what do I need to see? I need to see y's going up and going up by larger increments. So if I see going up 2, going up 1, heck no, that's concave down. And I didn't see the curvature at all. Does that make sense? This one I see going up 2, going up 3, maybe. I see going up 1, no, going down. Forget that, it's not going down. Going down, forget that, it's not going down. How's B? Oh, I can't read. I can't read. What did I say? The whole time I was saying increasing, increasing, increasing. Lo siento. I was saying increasing, increasing, increasing. So instead of concave up, just flip everything. Concave. Why did I say increasing? I don't know. Lo siento. But what that means is concave down. Oh, I already said it, but I didn't think it was the case. The increases will get smaller and smaller because G prime is decreasing. Well, that's the reason why that one's a no. Hold on, rethink. Oh, but wait a minute. These ones still show decreasing, and they said that F is positive. So my increasing is still true. So it can't decrease. The Y values can't decrease for G. We know that. Both of these, though, show increase, but only this one shows increasing at a slower rate. Thanks, Mag. I just read that word wrong. I don't know. Lame. Sometimes it's just the English. What else? Maggie.
Can you go over 92?
Yeah.
I don't think I know how to read a tangent line.
Oh, figure. There's a figure?
The graph, yeah.
Oh, there he is. Oops. It's just Y. Okay. The figure above shows the graphs of F and G, the graphs of the lines tangent to the graph. There's our -3 and there's our 1. B prime of -3. So you just did B prime of X, right? F of -3 is 1. F prime, remember whenever we think about like F prime and G prime, and we have an F, we have a G, we're thinking about the slope, right? And the slope of F is constant because he's a line, so it's just going to be rise 1, run 3. So I can substitute him for 1/3 because the slope of any line is constant. And then for G prime of 1, they showed me these tangent lines to be able to fill in that slope. Now, they were tricking me, seeing whether or not I would figure out I'm supposed to go here and not here. I need to go at 1 for G prime, follow that tangent line. I see a rise, well, a negative rise, down 1 over, ooh. So just approximate -1/2? It's not exactly, but it's close. So I would approximate. Oh, and there's only 1 even in that vicinity, so yeah, B. Thought it was nasty that it wasn't precise. They should have said approximate, because that does not hit at that crosshair. Little cheaters. What else do we have? 76 to 92? We done? 91. Oof. Okay, the accumulator function. We're allowed to use our calculator, yeah? F be the function, F attain a relative max. I don't know about you guys, but I need my brain to process whatever it is they're asking, especially when it starts to look confusing. So F prime needs to be 0 or DNE and change, not that I would write it all out, positive to negative, right? Because then I have a relative max. Easier to just take my F and get my F prime using FTC part 2, which would be F of, Justin said it a second ago, plug in the X. f of u, I can do f of u times prime, which is just 1. And then I would just go ahead and graph. X min is 1/3, X max is 1, just so that way I'm not looking beyond I should. And I can look right around the x-axis for any zeros, or I can look for vertical asymptotes. Like for instance, I see 0 is going to be a problem, but he's not in the interval, so I don't think I'm going to have any domain problems. Because cosine's domain is all real numbers. The only issue with the rational would be 0. He's not there. Don't have any DNEs to even worry about. Look for the zeros where we have the graph of the derivative, right? So all we need it is to change from, careful, specifically above. And if you find a 0 where it changes from above to below, it meaning the first derivative's y values, yeah, you got it. You got it. Anything else? 1 through 28, 76 to 92. I would. I don't think it's a bad idea. But if you guys don't mind, can you do 2 things for me on the very front of the non-calculated multiple choice? Actually, let me give you a paper clip because eventually you'll have all 4. Is that okay? Here we go. Yeah, literally. From their crazy copying thing. Yeah. Kathy, I'm going to send one back here. Oops. Yeah, I get what you're asking. I'm trying to think with the 2. There you go for you guys. Let me first have you working on the scoring. Can you guys on the front of the FRQs, can you give me plus how many right out of 28 for the NC for the non-calc, and then plus how many right out of 17 for the calc? On the front of your 2008, plus how many right out of 28 for the non-calc, plus how many right out of 17 for the calc? Maggie, let me just pull up 2018 FRQs real quick and let's check it out. So number right out of 28 for the non-calc, and number right out of 17 for the calc. You can add them together, your total multiple composite. That would be out of 54? No. Sorry, 1.2 times out of 45. 45, right? But that way you can see which one you're better at, the non-calc or the calc. I mean, take into consideration, we just saw that the calc was easier as far as percentage-wise, how many kids got it right. I guess we didn't specifically look at the 5s. I assumed the total percent would be similar for the 5s. The 5s got down to the 70s to the 40s there. Oh, thanks. The 5s got down to the 70s, 60s, 60s, 50s there. But here, oh yeah, yeah, the calculator multiple choice were definitely easier as far as how the 5s did also. But Maggie, you were asking about the shared FRQs. So if I'm looking at, for instance, the 2016, I think it's for CalcBC. Let me double check real fast. Yeah. Let's see which ones were shared. Yeah, it should be the same. I'm just thinking with the new formatting. Off the top of my head, I don't have that answer for you. So let's check it. You guys do not have a table. Oh, you do. The exact same? So you had one shared calculator. So far, one shared non-calculator. I'm guessing 2 non-calculators and 1 calculator is what my guess is. This one's similar but different. You guys are the BC version, they're the AB version. You guys have Eulers, they have slope fields. So similar but not the same. There he is, the funnel. Yeah, you both had the funnel. Now that there's 2 and 4, it's 1 shared calculator and 2 shared non-calculator. Yeah.
What kind of like, so for last year's AB FRQs, like there was like a formula, like there's always gonna be these ones on the test, kind of. You know how we like look back at like.
Yeah, but
With BC.
it's more than, therefore, like, depending on the year, you're going to have like 6 out of like 10 possible topics. The best place to go for that, I'm going to show you in your shared folder underneath advice, tips, and tricks. Isa, what's up, bud?
When grading the mock AP, are you going to use the BC, you're just going to use the BC score, right? You're not going to like combine them and then divide them, like the AB subscore.
I'm not going to give you an AB sub-score.
Yeah, so
Unless you come and you ask and you're curious, but otherwise, no.
so it's just going to be like,
Just a straight BC score, yeah. Maggie, if you look here, what to expect on the BC exam. Let me give you guys FRQs on the way out, 45 minutes using your calculator. There are 3 of them. But what to expect on the BC FRQs, that gives you basically the list of topics. Okay. There you go. I reformatted them so you kind of have like the APs spaced in between. Hopefully that helps a little bit. Did you see though the... It's 15, 15, 15, yeah.
That's a lot of money, thank you.
Yeah.
Do you think I could get the,
Yeah, let me pass these out, but then I'll get it to you. James, did you want both or do you want just the one? It's up to you. Both? Okay, I'll have to get it over there. You're good? Okay. Okay. Yeah. Sally, did you want both before your France or do you want to?
We had a problem like exactly like this like a year ago.
Yeah.
I have a bunch of biochemicals.
Oh, because your packets, yeah. So Hannah and Sally, you want the second part.
Thank you, Mitzi.
You're welcome.
Thank you.
You're welcome.
I have the one from yesterday.
Yes. Oh, is that you guys? The non-calc. No, you guys got the calculator yesterday. Okay, it's up here, I think. Yeah, here it is.